Let's do this problems today. This is basically a compiled list of this basically is from Blind Curated 75 problems that it had. So I have just extracted this array part of it, and this just deals with the arrays. And I'll also add all the other topics, different topics that the list contains. Okay, so let's start. Let's do the arrays today. So let's look at all of these problems, and then we will solve all of this. Okay, it is very good for your interview if it's coming up soon. Yeah. Oh well, I'm not a C++ programmer. Let's do it on this. Okay, given an array of integers and an integer target, return indices of two numbers so that they add up to target. Okay, so this is fairly very easy problem. You all might know how to do it. Since we have the target, what we'll do is we will sum any two numbers and figure out if the uh, final result is 9. We can do this in two ways, either going through two loops, starting at I from 0 to I length and j from I plus 1 to the finish, and then we can compute ai and aj when ai and aj are not equal. That's one way to do it. The other way, just to reduce that on square loop, two loops, is to uh, put these elements in a memory, and then we'll see if, let's say, if we are visiting the 7, then we'll check if 2 was already present or not. And if 2 is already present, that means okay, 7 and 2 makes up 9, right? So, why I search 2 is because 9 minus 7 is 2. So this is what I meant. Let's look at this. Let's implement a simple set. This is like a cache or memory where uh, we'll put all these elements. So for every elements integer number in our numbers, what we'll do is cache dot put. So what we'll put is uh, let's put this as C. Now if okay, let's put this as target minus this number, right? So let's say we have a 9, and then 9 minus 2 is 2. 9 minus 2 is 7. And what we'll say is, okay, if this cache dot contains, if this cache contains whatever our number is, since we are putting 7, that means this, and then this cache is a num. I mean, the next, so at first we put 7 while we are here. Next time we found 7, that means we should return true, because this number contains 7. So that means 2 was already visited, and we are searching for 7 next. Okay, if it has 7, then return true, right? This is what we do, and if not, we'll simply return false, right? I think this will be it. Oh, but what it asks is, given this 0 and 1, we want to find the index also. So now to put the index, what we can do is we can put map of integer, because we need to put the index. So let's make it a map, and let's start from int I equals to 0, and in, oh yeah, I should have done add, but I did a put, so that's fine. It's helpful now. I plus plus. So we know the index. Now if map contains this key, which is our num, then we will return new int array of our current index I, which comes later, and then we'll do cache dot get this num, the index of our num, right? So now I think this should be good. Now what happens? Only one value. Array 0 0. So let's just see. Okay, 0 and 1. Okay, this one is done. Now time for the next problem. Let's do the container with most water. So let's refresh the list. I think I should have a tick here, but it's not. But anyways, now we know this is done. Let's do the container with most water. Okay. Given n non-negative integers represents the point of coordinate whatever so that the two endpoints I is at IA1 and I is 0. You may not slant the container and n is at least 2. So here, so our input is from 1 till the very end. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So what we want to know is we want to find this, fill this whole rectangles which will have. So basically we want to find the whole area of this, right? So which will give us the maximum volume. Here if you see this, the difference between these two is 7, and the height is also 7, which makes it 7 times 7 as 49. So that is our maximum height. So how to achieve this? So one way to think about this is, so our maximum will at first, if they are widespread, that means the maximum, we can find the maximum there, right? So if this is 1 and 1 was, let's say, at 15th position somewhere here, or at 50th or 100th axis on x-axis, right, on 100th point, then this will give us the 100 area. 1 times 100 will give 100. But now, so we basically need to figure out our the whole width first, and then if we can shrink the width somehow and calculate the maximum every time, I think somehow we'll get this maximum. So let's say our maximum for now is so our maximum is minimum, right, which is 0, and then let's say our int start, we start at 0 and our end is at height length minus 1. So we put 2 pointers, 2 indexes here, I and at j. And what we'll see is, if you see just this example also, you'll see that, okay, now since the point at the end is the larger one, this will contribute to more area than the one which is shorter. So if these two are somehow different, and then if the size of this is smaller, then we increase the count of that point. Maybe if start is smaller than the end, then we just increase by 1 this index, start index, by 1 and make it to start plus 1, right? So that is the idea. So now let's do this. So while, so we can go till while they are in the middle, right? While start is less than end, what we'll do is, so if you check the area, so we'll just return max. So the total area is, so maximum here means max area, just to be clear, right? Area. So maximum area will be the max of all the maximum area that's found till now, or the current area. So current area is the difference between our total difference, that is end minus start. So our end is here at, let's say, 1, 0, 1. So this is 0, 0, 1, 2, 3, 4, 5, 6, 7, 8. 8 minus 0 will give us 8 times. So what we need to do is, if we fill the water, it will be till here, right? Only till 1. So that is the minimum of these two. Minimum, that means times math dot minimum of. So let's just put it in the bracket just to be more clear. So math dot minimum of these two heights, which is HEIGST height at the end and height at the start, right? So whatever the minimum is, and then the whole length times height will give us the area. So if that is done, what we'll do is we can't just go both the pointers, the higher the end pointer, we can't decrease the end pointer and just increase the start pointer every time. So we need to increase and decrease it based on the heights. So if, let's say, if height at end is somehow greater than height at start, then what we'll do here is we'll simply increase the start height, because we need to follow the next process. Else if they are somehow equal or less, then we can decrease the end. Now let's consider a point where we'll say, okay, if what happens if these both are equal, right? If these both are equal height, then can we just decrease end, or can we just put here? Just think about this. But let's see. Let's try to run this first. Okay. If height at end is greater than height at its start, somehow it is only printing 8. It did not print. So we can look at what's our heights are, or start and end, just to know where we are and to find out what went wrong here. Okay, we never increase. If you look at this, we are simply decreasing the end. If height of end, okay, 0 went to 1, and since this is very big, we are always at 1, and the next time we come here, 0 and 8, is this the problem? Yeah, I think that's the problem, right? Yeah, so anyway, since the height matters, even if the height of both these two values were same, and since they are very distant apart, so it doesn't matter if the value of this is smaller. That's why there's no need to check if height of end and start is same, because even if they are, then since we are considering the width, it doesn't matter if which one to decrease or increase at that time. So anything is fine. So we simply just decrease this end counter, right? So okay, this is also done. Now let's go to threesome. So given an array num of n integers, there are a, b, c in num, such that a plus b plus c is 0. Find all the unique triplets in the array which gives the sum of 0. Notice that the solution set must not contain duplicate triplets. Okay. See, so what is done here is, if we are given, so from this set, what we are doing is, say -1 and 2 is 0. So basically what we are doing is, okay, if we are considering this element, then from the rest of the element we are trying to figure out if it has +1, because that makes it 0, right? Yeah, because 2 minus 1 is +1 and -1 is 0. So 1 minus 1 becomes 0. That's how this came in here. So this is basically like threesome. This threesome is sounds weird. So this is twosome with all the indexes we need to consider, right? So this is basically like, okay, let me pull our twosome solution. can simply copy and paste and do it. Let's see. Okay, let's put it here, and then what we'll do is, okay, this is the two sum. If from every index we can find the two sum in the remaining index, then that will be great, right? Yeah, but we might need to tweak this a little bit because we want to know where our start and where our end is. Yeah, so that's why. Yeah, yeah. uh, so now what I'll do is iterate over all the elements in numbers. So for int I equals to, okay, let me just do it like this, nums dot length I plus plus, and what we'll do is uh, we will basically find the two sum. That's like, okay, uh, how about we include all the elements but not use our current index? That way, what is our runtime? But anyways, it's always n square. Let's see, I think this should be fine because the number of links is 3000. So 3 times 3 is 9. I guess that's okay. Okay, so int target will be, our target will be minus of our nums I, right? And int current index is, our current index is I. Then what we'll do is, for then we'll simply do this two sum, so which is a, let's say, list of integer. This one will return, then here list of integer, return list equals to array list. So return list. So now what we can do now is, let's pass it to this sum here. So we already have a written list, and if everything is found, we'll simply append it here, right? So let's do that. Then to sum into sum, what we'll pass is, we'll pass in this numbers, we'll pass our current index, which is simply I, and then target, because we want to avoid considering this element while doing the loop. Okay, another thing came in my mind is, since it says that the set must not contain duplicate triplets, so if this is already used, oh, I see, or I don't see, minus, okay, yeah. So basically, if this one is used, then the same elements should not be considered, right? Right. So that means we need a way to figure out if it's a duplicate. I thought I can just go ahead and check it, but if you look at this scenario, even this will yield to 101, and even this result will yield to 101, but we are avoiding 101, so that looks fine. So what we can do is, we can basically sort it and then compare if uh, or we can also do if okay, let's see about that. Okay, somehow we can just simply skip it. So instead of list, we can simply put a set, and then in a set we can compare this. But anyways, Okay, to sum of this, and then we can provide the return list, right? Return list. Then what we'll do, we have a map of cache here, where what we'll do is we do not want to return it here yet. So for every int current index, int target, list of return list, right? So if this map contains this remaining two, what we'll do, we'll add it in return list dot add so what we can add here is int a equals to 0, int b int a is equals to our nums at current index, int b, the next element that we are going to put here is target minus num, and then the third index that we are going to put here is our I, because that is what it is, and then so yeah, int array return will be new int array of this a comma b comma and c. What if we sort it, arrays dot sort arrays dot sort this return, right? So we have this sorted order, and then once we have this, what we can do is, so now this -101 and -101 from here, both are found, right? From, if we consider from this index to the all the remaining, we are just simply going it. So now that means if this I'm just thinking that since I have to loop, I don't want to loop through all my return list. So I need a certain way to see if all these array elements match, right? So for that, one thing I usually do is put it as string and later on break it. So let's say if I have a list of string here, right? This is just some example of how randomly we can achieve this, but we can, so in a cache we have this, and yeah, so what I'll do is and then this won't be this, it's notice that the solution set must not contain the same triples. So even other, let's put it as a set of return list, right? Set of string and return list. So if return list does, and since this is a set, we can simply put all the elements just like, okay, ret 0 plus ret 1 plus ret 2 with a delimiter which we can put as dash, right? Or we can simply put this as a delimiter. So 3 elements, if we put it in a list, if this is a set, I think this will give us a unique element. So -101 will come twice, so that will be it, -1. And since it's a string, I think this should be fine now. Or we can simply, what we can do is, since we have this integer array here, we can run through a comparator and compare all these 3 elements and do it. That's also fine, but yeah, I don't want to write comparator for now. Anyways, so now what we did here is we will simply return our return list. We can also not return anything and just make it a void, because this set will already contain everything, so let's not return anything, right? uh, okay, so just walk through what we did till now is, so for every element, let's say we have -1, right? We made it +1, and we made, okay, and then from all these elements, for all these elements, uh, we need to do this. If I equals to our current index, then we'll simply continue, so that the same element is not used, and then the rest remaining everything is used. uh, 0 will also give the same multiple times, but that's fine, and from everywhere we'll simply check it. Or we can simply go in the forward direction, but I think given the size, that should be fine, right? So current index continue, and if cache contains the, now this is just the two sum that we had earlier, nothing much here. uh, Contains the same number, our target is positive, so we need to find +1 from the remaining, which is 0, 1. I think this should be fine. Let's see, incompatible type, oh yeah, this one should be hashed. Now what I see is, now for every string s in our return set, let's make this return set uh, int list of integer, list of integer return list equals to new. Let's format our output as well, because we will need this. So what we'll do, so we have our string in our set is s, so we only know this, right? This is all the elements, and then what we'll do, string array of elements will be all the numbers will be split with, so since this was our delimiter, we have 3 strings, then since we want to, okay, this is integer val is equals to list, then what we'll do, for every, so every elements we are just putting it in values, so nothing fancy here. Integer the value of this element. Now we'll simply put this and add values, right? Incompatible, which cannot be converted. Oh, this is not a written list, but written set. List of listening cannot return a set of string. Where? Do set, but add. Okay. Now if you see, what we received is, why on earth did we receive -1, 1, and 1? Let's think about this. This is somehow wrong. So our sets will be new every time while we are computing this. So No, should not be that. Okay, it's somehow. Oh, since a plus b plus c is 0, I think just this should be fine. Because, yeah, it's not minus 1. Uh-uh. Our output is, okay, let's, so our target is minus 1. Our target is 1. And if I is, so I plus plus. Okay. Now, because if that element was found, we are simply bypassing it, so I should increase it by 1, and from the remaining one, we are simply thinking if sometimes this. Hmm. Oh, this is not I, right? This is our current num, right? Yeah. Yeah, I think this looks fine, right? Um, okay. Time limit exceeded for all the zeros. Okay. Now what would be written now? Let's come back to this a bit later. Uh, let's do, but let's see. So we have all these elements. So from here we are searching. So if we do this, huh? Anyways, it's fast though it's slow. Basically, yeah, that's fine. We'll see how we can improve on this. Okay. Uh, then okay. At least these three are done now. Let's do this. Search in rotated sorted array. Search in rotated sorted array. So you are given an integer nums sorted in ascending order, right, and an integer target. Suppose that nums is rotated at some pivot unknown to you beforehand, might become this. If the target is found in the array, return its index, otherwise return n. Nums is guaranteed to be rotated. All values in the nums are unique. Okay, this is something interesting. So what we can do here is basically find the point where it is rotated, and then we will find where our value is. Okay, so for that, let's say if our int start is, or int, let's consider low as 0 and int high as our num start length -1, then what we'll do is, while our low is less than high, what we'll do, mid is equals to, always do this guys, low plus high minus low by 2 to find the mean, instead of doing high minus, instead of doing low plus high by 2. That's how you do it, right? Low plus high by 2, do low plus high minus low by 2. That way you are protecting yourself against the overflow, because low might be at the very last index and high might be very large, and if you simply add those two numbers to do a division between those two, it will, that addition will be very big. So what you want to do is, you want to find this number plus with the added index of the large minus just the low number, and then do the division. That's much better, preferred way to do it, right? Now what we'll do now is, since we have the mid is okay. Now to find this pivot, what we need to do is, since it is rotated at some point, right? So let's say our mid is here, then what we can say is, if our nums at, let's say if the num at our high point, right, or at low point, if our, let's say we are here, and if the low point is smaller than this high, right, so if our low is less than, if this low is less than number at nums at our current mid, that means this is not rotated yet, right? And if we put our low here and our mid will be here, then we can see, then we can come, no, I think this is false. So what we'll do, because if our low is here and our high will be, mid will be 1, and if we are considering this low as mid, we can't simply put this, we can't simply say okay, high should be here to find. So the odd thing is here, this one is the odd thing. So if our mid is greater, if our mid is greater than the high point, so if our mid is greater than our highest point, then what we are sure is that the number, small number, is on the right of it, right? So what we'll do, since this is high, this has to be low, so we'll simply make low is equals to mid plus 1, right? So let's consider this as, because this cannot be the lowest point, so our low will increase, right? Else means to say, okay, our midpoint is still smaller than this, then this can be the midpoint. So what we'll do, we'll simply make this midpoint, high point, as our mid, because if this was the mid and our mid is still smaller than the high point, that means let's put this as high, and then we'll see, okay, this is the mid, right? Yeah. So now what we can do now is, we found the mid index, right? So our integer of rotated index is the point where the midpoint was found. That is basically our lowest point, is where our value is found. So that is low, right? Now our target. Now let's look at the target. So now if this low point is where our index is, so what we can do is, either this target is within this range or on this range, somewhere in this two, because this is a sorted array, right? So now what we can do is, if this target, if our target, whatever is there, is uh, greater, if this target is greater than the num at uh, nums dot length minus 1, right? If this number is greater than this nums dot length minus 1, which is this number, if it is greater, then it is on this side, right? Then it is on the other side. So our low will be low, low will be 0, and at that point our high will be, so we need to search still here, right? So our high will be this rotated index. So from where it was rotated index minus 1, because it is on the left side, right? Yeah. Because the no target is greater than high, so it must be on the left side of it. Now, else, if the target, our target, is smaller than the high, then it must be within this, right? So our low will be our current row, which is the rotated index. Simply, since this is already rotated index, so we can simply say that, okay, our high is nums dot length minus 1, and low, we don't need to set it, but still, yeah, right? Now these two values are sorted and we know the high and low. What we can do is we can simply uh, we can we can simply do a binary search and find if the number is there or not, right? So to do a binary search, what we'll do is, while low is less than high, again the same thing is here, mid is this, right? And then what we'll do, if our current target is less, if our current target is less than mid, of course, if our current target is or less than mid, then what happens? If our current target is less than the mid value, which is, or we haven't said that, that is, target is less than norm of mid, right? Because norms of mid will give us the value. So if this is less than mid, then the number will be, if the target is less than our current mid, then the number will be on the left. So high equals to high equals to mid minus 1. Now if low and mid is same, if nums at mid is equals to target, that is, if it is found, then what we'll do is we'll simply return this index at mid because it is found. If not, then we'll do this, else if the target is greater than or equals to low, then our low will become mid, right? And if nothing is found, we'll simply return minus 1. Oops, oopsie. So let's see what happened. System dot out dot gallon. 0, 1, 2, 3, 4. So 4 is our lowest point and high is our lowest point. Rotated index is at 4th, which is correct. And then what we're doing here is we have the low and high. So let's see if it's fine. So 4 and 6, 0, 1, 2, 3, 4, 5, 6. So between 4 and 6 is where our number is, right? And then what we are saying is, okay, what we can do is, if now in our loop we have this 4 and we found the mid, right? It's not it, so what we are doing is it's not it and the target is lower, so we are simply doing high equals to this. So we can go till low equals to high and then find the result in this case, right? Or we can simply check at the outside if that was present. Time limit exceeded. What happened here? 1, 3, and 2. 1, 3, and 2. What happens with 1, 3, and 2? So it will find the mid as low, and okay, low is always mid, high is never changed. Okay. If return, what we can do is, if numbers at whatever our low is target, then return low, else return -1. Because every time it was on this low, so it was time limit exceeded. Huh. Okay, so what happened here is, let me quickly print this. I think I now know what is happening. So our low and high, uh, low is every time the mid, right? So that is the same mids, the same low every time it is 0 and 1. See, 0 and 1, so 0 is high. So now what we can do is, if this value at, or we can simply put our mid as nums at mid plus 1. So now, since we are here 0 and our mid is also, if mid and low are the same numbers and nums of then every time it's going to be the same thing, I guess. So that means this didn't happen, and we can simply return -1 here. I think it is better if we, so instead of comparing if target is less than mid, because every time we are getting the medium value, so we can compare if target is greater than mid, right? If target is greater than mid, then our low changes, else high will be mid and low will be mid plus 1, because target is greater than our mid, so let's keep that as that, and then high will be uh, either that or that. So this makes more sense to me. Yeah, yeah, guys. Just these looping things are sometimes, it worries me. You see what happened here? Just because we have this, we are always pointing towards low, the value towards the low point was always there and it was doing the time limit exceeded, and then we simply changed it. It's just some error. And then next time what we have to do is, if we are comparing this low point, make sure the low point is always increased, because that's our breaking point, right? uh, Something even I realized now. uh, yeah, and then the high point is this mid. Now you can keep the high point, that's fine, but this low, because our mid will always come towards the lower base whenever we are doing this. So yeah, that is something you all need to realize. Just think about it, right? I think this is also done. Oh man, now let's look at this maximum sub array. Okay, given integer norms, find the constant which has the largest sum and return its sum. Okay, this one. So this is basically Karane's algorithm that we use, and we don't need to look at every sub-array here, and we can simply, what we can do is we can go through each element and have the running count, and then update the our maximum result as we go on. This can be achieved in ON time. So what we do here is basically int running sum. So for now running sum is 0. Then what we do is for every integer num in nums, so for every integer num in nums, let's say our maximum sum, let's keep another one, maximum sum equals to 0. So our maximum sum is something that we return maximum sum. Then what we do is we can also do this maximum sum as integer dot mean value, right? So maximum sum is equals to max of our current maximum sum or the running sum, right? Maximum sum or the running sum, but our running sum will be updated here. So if running sum is less than 0, because we want to update it every time, so running sum is less than 0, then our running sum will become 0, and then running sum will be running sum plus num. So what we are doing here is, every time we go through this, let's ignore this, let's say we have 4 and our running sum is 4. Until it is decreased, this will always be increasing, right? So it's 3, our running sum is 3, and if somehow it goes below this after 5, let's say it goes to -2, we want to update it and make the running sum as whatever it is. So -5 will start again, and then will go like that, right? Because this one was negative, so the next time we'll start. Now if it is 0 again, let's just test. If it is -2, what happens is, okay, -2 is less than 0, so we are at 0. The sum is -2, and that is our running sum, right? Yeah. So this is also done. Best time to buy and sell stock. Not sure why this doesn't show. Okay, best time to buy and sell stock. Say you have an array for which the item is given, is the element in the price of the given stock on day I. If you were only permitted to complete at most one transaction, that is buy one and sell one share of stock, design an algorithm to find the maximum profit. So we are only permitted to find this is also a famous interview. Okay, let's do this. Now, uh, so the problem is, note that you cannot sell a stock before you buy one. So you need to buy one before you sell. That means you need to know the minimum count and then go to the maximum possible, right? So you can have the maximum profit. So let's say our int minimum value is at 0, and int, so since you need to sell, right, profit is also 0, right? So to sell you must buy, right? So that's the thing. Let's say our integer minimum value is math dot integer dot max value. Now then, for every element, for every in prices, what you'll do here is you'll update our minimum value with the value that we have, that is our minimum value will be, so since we need to buy, our math dot minimum of our minimum value comma our current price. So 7 is our minimum value, and then profit will be math dot maximum of this current price. Well, because you'll always buy it the next time, right? So this will always be the current profit or the time when you bought. Let's say you bought at once, because it's the minimum value, and whenever you are going, you'll simply subtract our current number, that is our price, because we reached here, which is 6, and then you want to do minus the minimum when you bought it. So the minimum value is value. So this is how you calculate your profit. And yeah, because if you buy at 7 and sell at 1, you will have a profit of negative values, and since the profit is 0, so 0 is the true one. So we'll simply return our profit. This is well known, so I was able to come up this quick, but make no mistake, this is not an easy one, and let's just keep it like it is. At least who am I to say all those words? Okay, this is not bad. Where are we now? Maximum product array, right? So what we are doing here is the previous one was maximum array. Let's see this problem and see this problem. So this one is maximum product array, and this one is maximum array, right? The one we recently did. I guess these are similar, but this one is an easy problem and this one is a, let's see what it is. So given an integer array nums, find the contiguous subarray within an array containing at least one number which has the largest product. So what we're doing here is, since 2 times 3 is 6, so that's the maximum product, right? Yeah. The result cannot be 2 because minus 2 and minus 1, this is not a subarray. So the product should be continuous. See, what differs in a product is just the negative numbers, right? So if, let's say, we have two negative numbers in this number, then as a whole this will become a very large number, because negative negative cancels out to become positive. So what we can do in this is, let's say we have integer minimum and maximum, right? So we'll keep a counter of 2. So whenever we have the minimum, we'll keep this minimum there, and next time we visit something less, we'll simply find the maximum between the reversal. Then I think that should be okay, right? So for every integer I, let's not I, for I less than nums dot length I plus plus. So what we want to do is, okay, let's keep the current count, and maximum is equals to max is equals to math.max of max, or current product. So let's keep our and current product is equals to 1. So current product times nums at I, right? So we'll simply return maximum whenever it is a maximum. Now let's say if somehow this nums at I is less than 0, right? If this number is less than 0, that is negative number, minus 2. So in that case, what we do is, in that case what we can do is our maximum our minimum will be current maximum. Let's just keep it like this, because whatever the product we have, right? So in this scenario, let's see. So we multiplied this current product by every number times 2 times 3, it became 6. Now there comes minus 2, so 12 times minus 2 is 12, right? So we want to keep a hold of this. So our minimum is our maximum. So think about this. Now it goes to the next value 4, and if it was a negative number, then we want to have maximum number as maximum times that number, right? So yeah, so our maximum number, now if it is altered, then our maximum number will be current max, and minimum number will be minimum maximum times our minimum will be maximum times this nums I, which will give us negative number, and maximum will be the max of our current max or mean, right? Because let's see, we have 2 and 3, we are simply doing the product of these two. Simply let's say maximum equals to, let's not put that thing there, and we'll simply say maximum is equals to maximum times nums I, right? So 2 times 3, and then as soon as we have a negative number which is minus 2, uh, then what we are doing is, let's put this in else block. If it is not a negative number, right? If it is not a negative number, uh, then the minimum number becomes maximum minus 2, which is minus 12, and then it is looking for the maximum, and the maximum becomes, okay, this is the current running maximum. So let's say our minimum is 1, and what we're doing is maximum times this current number will give minus 12 to a minimum value, and then in the current maximum will be, so next time if this was minus, then our current running maximum or the maximum as a whole, right? So we need a current running max is 1, so our running max will become running max, which is 6, and as soon as this goes here, so this will be running max or the mean, whichever it is. Then our running max will again initialize to, yeah, we simply, then our max will be running max or max, right? So what I'm trying to do here is, let's see, we have a running maximum of, maximum can be anything anywhere. So maximum is running maximum or our previous maximum. Running maximum at 2 will be minus 2, then 3 will be 6, then as soon as it finds minus 2 negative number, so what happens is our minimum will become uh, minus 12, right? So if it becomes minus 12, then if it becomes minus 12, then we can simply put running maximum is the maximum of between. If this is a negative number, then which has the largest product, yeah, either, so running maximum will be this nums I, or because even this can be a product, right? That's why nums I, which is a negative. I was just thinking about this scenario. So our running maximum will be 12, or if minus 12 are our current minus 2, and then the next time it goes to 4, what happens is, this is negative, so running maximum is, so okay, this has to reinitialize, right? So running maximum is something something is wrong. Max is equals to 1. So we start both our minimum and maximum. So now our minimum is nums 0 and our maximum is also nums 0. Our running maximum, so this will be nums 0 if and only if nums 0 is less than 0, then nums 0, else let's simply put 1, right? So now when we are here, let's say we have, then our running max is simply max during the start, and then so for every integers in here, what we're doing is if nums I is less than 0, which is not, so our running maximum is maximum times nums I, which is 6. So we update our max to 6, then running max. Then it comes up here and it says it's a negative number, and it enters this minimum array, which is minimum is equals to, let's say we already had a minimum before, that means if, since this number has to be multiplied, what if we simply do running max is equals to I think I need to take a break and come back again. So now what happens is, if, what is the problem, this is just 3, that is because our running max is 1 and then our maximum is running max and max. So yeah, since we multiplied it here, it will become just 3 times, since this is positive, which is 6, it will be 6. Since it is 1, no, it had, we didn't put 2 in there, right? So let's just keep it as max, right? So our running max will be max, so this 2 will be included. Yeah, okay. Now let's see this test. Okay, 0. Well, how about -2, -4? Yeah, so here is the problem. So okay, that means something is wrong. So in this case we need to multiply all, right? It's so basically what we have to do is this running max should keep on going and multiplying. So this whatever is our running max should multiply this number because, and yes, if you see this number was a negative, so it was the very low value. Now since it is multiplied, it becomes the maximum value, right? So that's why we have min and max. So if we just say that, okay, let's just transpose this to saying, okay, if our temporary is max, right, max, and int max, no, maximum is minimum, and minimum is maximum, then what happens is, so we'll keep this. Min will be the multiplication of those two, but we can just keep it outside. So what we're doing here is, yeah, running max will then be, okay, running max times nums I. But if this number was 0 here, then the next number can also be the maximum, right? So we'll just keep, okay, nums I, or the value that starts. Let's say this was 2, 0 and 1, or 2, 0 and 5. The running will give 2 times 0 times 5, which will be 0. But what we want is the maximum number is to be 2, 0, and as soon as it finds 5, then we need to have that 5 as the maximum. So either the maximum of this nums I, comma, running max times nums I, right? That will give either the whole or just the part of it. Similarly, we'll also keep, so now the minimum is equals to math.min of nums I. So if this is all negative, the same scenario, or just this is the most minimum, that is running, not the running, but minimum. We have the minimum, right? So either the minimum times so whatever the current value, which is nums I. So if we do this, and then we just update this max will be the max, running max will be our maximum times that, and that. Let's see now. Okay, 6. So what we're doing here is, let's keep our minimum value as nums of, our first element is our minimum. We don't keep 0, so let's just keep the first element as minimum, and maximum is also the first element, running max is also the same thing, and then we go from there. The next time we find, then we do this update, right? Let's see. Okay, it's still the wrong answer. Why is it a wrong answer? Minimum So now if we see, we have the first value, which is the minimum, comma, maximum, and running max as this. Why is this failing? Let's look at the first example, which is this. Why is it 4? Why is it just 4? Oh, 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 oh. No, but max should give the max, right? does the overlap? Let's look at this very carefully. If minimum is either the minimum of those two, but for us, where is it for? Let's just see this. Let's just see our max. What? Why isn't why? How is our max updated? Oh, this should not be a max. This should be a running max, which should be updated, right? Yeah, I think this should be good. Okay, still not good. Uh, okay, this temporary variable should again be a max. Uh-uh. Whatever is our max is our max. Mm, 9. How is this 54? Oh, 9, 6 of 54. Six. Not on this man. Okay, 18 and 54. Okay, if we say this, maximum, if the value is lowered, then at first both of these are changed. So this norms I becomes minimum, which is also 0, 2, 2, and maximum is also 2. Oh man, don't you know how to swap? Finally, but still very slow. Anyway, not too bad. Okay, where are we? Okay, let's do this too. Oh, I think with this, our four of the problems will be solved. Uh, so this is done. Suppose an array is sorted in ascending order in rotated and order is rotated at some pivot before you find this is I think something what we did earlier also find the minimum element. So this is something similar to the one I did here, right? So what we are doing here is yeah, this is what we'll do. So our lowest point and highest point we know, and we'll just find if this is the mid, then if the num at this mid is greater than the number at height, then we know for certain that the value lies here, and whatever is in here is the value. So find the minimum element. So the minimum element is return nums at low. Very similar to the same problem. Not very similar, exactly the same. You can say that. That was a bit difficult than this. And not difficult, but you basically had to do the binary search after this. So I think this will be good. Yeah. Okay, this is done. Contents duplicate. Given an array of integers, find if the array contains duplicate. This is very easy. This is okay. Say it as this is a very basic thing. I think you all know this. I don't need to explain. I'll just type. Product of array of numbers of n where n is sorting rotated. Oh yeah, we did this. Oh, this is the last one we have now. That's really good. Given an array n, well, it's guaranteed that the product of elements of any prefix or suffix of the array, including the whole array, fits in 32 bits. Solve it without division and in OM. So basically, if you think about this product of array except self, right? So what happens is, let's consider you have this. Let's consider you have A, B, C, D. Then the product at C is except self means A times B times D, right? This is what should come in C place. At A place it should be 1 basically because, oh no, at A it should be BCD, B times C times D. At B it should be A times C times D, and at D it should be A times C times D, right? Yeah. So just by looking at this, what we know is for any number we need to multiply whatever is in its left and whatever is in its right. So how about we construct an array which will keep let's say this is our int array uh, temporary array, which is new int array of the same size, which is nums dot length, right? Nums dot length. And then what we do in this temp array is we simply multiply all this value. Int current number is equals to 1, right? So on a place, let's say we have 1 on the left, so because whatever multiplied by 1 is the same, so on 0th we'll keep whatever is in the left times whatever is on the right, right? So let's do that. Let's do, okay, for every integer I in equals to 0 till I less than non-step length plus temporary of I is equals to, so in this first section of temp I, which is on A, what we should have is we should not have A, but we should have the value in the current. So let's consider this current will keep track of all these multiples. So if on this 4th it will be the multiple of these 3. If we do that, then temp I will be what will it be? Simply current number. But in later we will multiply it with nums at I, so that on the second place it will have A and it will put A in there, because for B it requires A times C and D, right? So now by doing this till last we have all the numbers from first. Okay, we have that here, and what we do is again int temp is equals to 1 and for int I equals to, now since we already multiplied everything from left, now it's time to come from the right, so that for C everything from the left is there, now we need everything from the right, so nums dot length minus 1 I greater than equals to 0 I minus minus. So what we do now is, since we already have temp, so tmp at this current index is at D we have already multiplied A times B times C, right? So we will need temp I, whatever is the temp I, times this current number times current number, and our current number will be D, so that for C the D can be used, right? So the D is nums I, right? And then we can finally return tmp. Don't need to initialize that. Okay, I think this is good too. Cool. So let's